Right then, we're on to our final topic in Chemistry 2. So this is topic H, and it's chemicals from the sea. So, a couple of things we need to think about. This is really based around salt water and the idea that there are certain things we can get out of salt water. Now, sodium chloride, I hope we all know, is the chemical name for table salt. So it's used as a preservative and a flavouring, but sodium chloride can also be used as a raw material for chemical reactions. So it's used in an awful lot of industrial processes. Sodium chloride is also a source of chlorine, which is again something that we use in chemical reactions a lot, and again sodium hydroxide. So this is just all about how we're going to get that from salt water. Well, I say from salt water. There are two ways we can get sodium chloride. One of them is from getting it from the sea, and the other is from mining salt deposits. Now, they'd like you to know that we mine rock salt, so that's solid salt, in Cheshire. Now, the downside to doing this is that it's led to subsidence. Now, subsidence is basically where the ground sort of gives way. Now, if you're mining underneath and you sort of mine a big hole, then the land above can start to give way and drop down. That's what we call subsidence, which is a problem if there are, for instance, houses built above the ground that start subsiding. And the other way that we can get sodium chloride is from what we call solution mining. So basically we get salt water or brine, and then we do some chemical reactions to get the salt out of it, or the sodium hydroxide or the chlorine. Now, the downside to that is that the brine can escape, and if it does and it gets into local habitats, it can have negative effects. Basically, it can just damage the wildlife and the plants that are growing there. So, this is another example of electrolysis. So remember, electro meaning, electricity, using an electrical current, and lysis meaning to split. So, we do this with our brine. So our main solution in here, stuff we've got in this solution, is just brine. Then we have two electrodes. Now they have to be inert. Basically that just means they won't react with anything. Then we run a current through them. So we have our negative cathode, where hydrogen is produced, and our positive anode, where chlorine is produced. And then after we've finished doing the electrolysis, what was our brine solution becomes sodium hydroxide. So we get sodium hydroxide in the solution, hydrogen at the cathode, and chlorine at the anode. Now, chlorine is something we need to know how to test for, and the way we test for chlorine is we use some damp litmus paper. Now, if the litmus paper gets bleached, so it goes white, that shows that there's chlorine present. And if we wanted to test for the hydrogen, you don't necessarily have to know this, but what we'd do is we'd collect the gas, and if we put a lighted splint in there, we'd get a squeaky pop. Basically, it just sort of explodes and sounds sort of squeaky when it does. So that's the test for hydrogen. For the higher paper, we need to know some equations about what's going on. So you need to know that the H+ ions are going to the cathode, and we have two H+ ions, and those two H+ ions pick up two electrons, and they become H2. Now, we have to have two H+, because hydrogen doesn't go around on its own. It only goes in pairs, so we have to end up with H2 at the end. So we have to put in two hydrogen ions, so we need to have two electrons to make them neutral, which gives us H2. So at the anode, it's the chlorine ions that go there. And again, we have two chlorine minus ions. Now, the minus means they've got extra electrons, so they need to lose two electrons. So it's minus two electrons this time. And they go to make Cl2. So once again, chlorine doesn't go around on its own, so we have to make Cl2. So we have to have two chlorine ions, and we have to lose two electrons. Now, in the solution, we are left over with some sodium ions and some OH minus ions, so Na plus and OH minus, and they just combine together to make NaOH, which is our sodium hydroxide. So these are the three equations that you need to know, and you need to know which ions go to the cathode and which go to the anode. Okay, the last little thing is on the Chloro-alkali Industry, which is basically what we've been talking about here. It's the making, the electrolysis of the brine to give us the sodium chloride and to give us the chlorine and the sodium hydroxide. So for the foundation paper, you just need to know that we use sodium hydroxide to make soap. For the higher paper, they'd like to know that hydrogen is used in the manufacture of margarine. Chlorine is used to sterilise water, make solvents, plastics, so it's in PVC. And chlorine and sodium hydroxide can be reacted together to make bleach. Just need an example for use of each of the components really, so one for hydrogen, one for chlorine, one for sodium hydroxide. They do quite like the bleach thing though, so it's worth remembering that chlorine and sodium hydroxide go together to make bleach. Okay, and that is it for chemistry now. So I would suggest going back through and just having a little revise of everything. And don't forget, if you've got any questions, do not hesitate to ask.